Client server and file server. Welcome to today's presentation on client server and file server architecture. In this session we will explore the fundamentals of these architectures, examining their history, benefits and challenges. Let's embark on this journey to understand the core principles behind client server and file server technologies. Initially, PC networks focused on file sharing were with a simple architecture. Multiple personal computers shared a network with a central server for file storage. Applications ran on the client PC and entire files were transferred from the server each time data was needed. This setup was efficient for small networks with few computers and limited file sizes. File servers require a locking mechanism to prevent multiple computers from accessing or modifying a file simultaneously. The operation system needs adjustments to track file usage and address potential issues, but these file servers are ideal for small networks with a few computers and limited file transfers. Early file servers implementations aimed to address the limited storage capacity of PCs by utilizing the server's ample storage resources. This ensured that organizational data remained centralized and up-to-date, simplifying backup procedures. However, the original implementation required transferring entire files whenever information was needed, leading to inefficiencies. To overcome this limitation, a more flexible architecture was developed. Files on the server could be mounted as virtual drives on local computers, allowing application to access only the required information without transferring entire files over the network. Similar architecture is employed in database applications, where data resides on the server while local computers run copies of the database management system software. Processing occurs locally, but data storage remains centralized on the server, reducing unnecessary data transfers over the network. The limitation of file server architecture spurred the development of more advanced client server architecture. In this implementation, file server is replaced by a database server. Applications communicate with the database management system to send queries and receive results. The database management system accesses the database, retrieves only the necessary data and sends it back to the client, reducing data transfer significantly. Unlike file server architecture, where most processing occurs locally, client server architecture divides processing between the client and the server. Benefits of client server architecture. Developing distributed applications, including distributed data, is convenient. Data can reside on remote servers, even at different locations. Services can be migrated between servers seamlessly, without affecting local system behavior. The network is not overloaded with transferring unnecessary files. Application execution is divided between the client and the server, preventing unnecessary hardware upgrades. When upgrades are needed, services can be migrated seamlessly without interrupting user work. Drawbacks of client-server architecture. Organizational data dispersed across multiple locations can lead to challenges in creating a unified data model, resulting in duplicates and integrity issues. Managing data resources across dispersed locations may require additional effort and resources. Clients may not be aware of all available services, necessitating the implementation of a service discovery mechanism. Client-server architecture involves local PCs performing computational tasks. This approach recognizes PCs as standalone computers capable of supplementing central computing resources. Local PCs are better suited for certain tasks due to their proximity to user, such as handling input and output. So from this we hear two main models. First one is a thin client and a thick client. Thin client configured with minimal processing capabilities, relying heavily on the server-side processing. Thick client equipped with more processing power and capable of handling a significant portion of computing tasks locally. Thin client architecture. Thin client setup minimizes client processing and storage tasks. Server handles majority, while client focuses on data entry and display. This is favored by users accustomed to mainframes, where central computer dominated operations. Implementation. Most work centralized on server, with clients providing minimal support. Thin client setups demand robust servers to manage workload efficiently and to avoid bottlenecks. Resembling traditional dumb terminals, thin clients offer enhanced capabilities. Thick client architecture. Thick client refers to a powerful computer that handles significant processing tasks locally. While the server manages the database, local processing and display are conducted on the client. Initially, thick client setups posed difficulties in software management due to local storage. Upgrades were complex and time-consuming. Evolution. Over time, tools were developed to address limitations of thick client setups, simplifying software management. Remote installations have become the preferred method for managing decentralized systems, overcoming challenges of thick client setups. Client-server architecture options. There is a two-tier architecture and a three-tier architecture. Two-tier architecture. This setup involves two layers: the client layer for user interaction and the server layer for data storage and processing. Three-tier architecture. In this model, three layers are present: the client layer, an application layer for logic processing, and the server layer for data management. Two-tier architecture is a simplified architecture with direct communication between client and the server layers. Three-tier architecture offers enhanced scalability and flexibility with an additional application layer separating client and server functions. Considerations. Two-tier is suitable for small-scale application with straightforward requirements. Three-tier is ideal for complex systems requiring separation of concerns and scalability. Two-tier architecture overview. It involves a local client and a remote server, splitting processing tasks based on client type and application design. Database management system and procedures reside on the server, simplifying application development. It is ideal for scenarios with a limited number of users. Performance may degrade with many users. Scalability, complexity increases with the client growth. Three-tier architecture overview. It is developed to overcome a limitation of two-tier architecture, adding a new layer between client and the server. There are various approaches on this layer, including message servers, application servers, and transaction monitoring. It provides queuing services, removing execution burden from the client. It is useful for many clients, adaptable to changes and integration of new servers. Here is a mainframe architecture. The figure illustrates a scenario where the mainframe handled all execution tasks, while the client primarily focused on basic data entry and output services. Here is a thin client architecture. The local computer manages only the presentation layer, handling input and output without requiring a high-performance processing unit or extensive local storage. Instead, all business logic, applications, and data storage reside on the server side. Thick client architecture. This illustrates a distributed process where tasks are split between client and server. The database management system and data reside on the server, while the client executes some application tasks locally. Due to this split, a thin client is unsuitable. On this slide, we can see the thick client, which is equipped with an enhanced setup, capable of running the entire business logic layer along with the portions of the database management system layer. Thin clients need less hardware compared to standard PCs. The client have lower total ownership costs compared to standard PCs because of their simpler configuration and easier maintenance. Thin clients has enhanced security against malware due to the absence of local storage, although servers can still be vulnerable to attacks. Thick clients, however, require more powerful hardware for local processing. Thick clients have higher initial costs, but they may reduce long-term expenses by relying less on servers. Also, thick clients architectures offer better performance for resource-intensive applications. Storing data locally possesses security risks, but advantage is less server dependent. And here are some conclusions. Concerning hardware, thin clients need minimal hardware. However, thick clients require more. Costs. Thin clients are cheaper to maintain. However, thick clients may have higher initial costs. Performance. Thin clients rely on server, while thick clients handle tasks locally. In security, thin clients are secure against local threats, but depend on server security. However, thick clients store data locally, which can be risky. Choosing between these two architectures depends on organization's needs and infrastructure. Each has distinct advantages and trade-offs. Thank you for attention.